Pluto, a distant and mysterious celestial body, was once considered a legitimate planet in our solar system. For many years, it held a special place in the hearts of astronomers and stargazers alike. But recent statements by leading astrophysicists like Neil deGrasse Tyson and Michio Kaku have brought Pluto back into the spotlight. They have raised concerns about Pluto potentially being on a collision course with Neptune. How is such an event possible? What would happen if these two distant, celestial bodies collided? Could we be witnessing a cosmic anomaly, or is there more to this situation than meets the eye? These questions have fascinated many and led to numerous studies exploring the intricacies of Pluto's orbit, and its relationship with Neptune. Once considered a planet, Pluto was later relegated to the status of a dwarf planet. Despite this, it continues to capture the curiosity of astronomers who are keen to understand its behavior in the vastness of space. Studies have revealed that Pluto's orbit is precariously close to that of Neptune, which has caused astrophysicists like Tyson and Kaku to voice concerns. Could a collision between Pluto and Neptune pose a significant threat to Earth? The potential consequences of such a colossal event are intriguing and worth investigating. Pluto's orbit around the Sun is unlike any other planet's. It takes an astounding 248 years to complete just one orbit. This means that since its discovery in 1930, Pluto hasn't even finished one full orbit yet. However, the intrigue doesn't stop there. Unlike most planets, Pluto's orbit is marked by an unusual eccentricity. It is not a perfect circle but rather more of an elongated shape, which makes its path more unpredictable. What makes Pluto's orbit even more fascinating is its 17 degrees inclination relative to the ecliptic plane. Most planets in the solar system orbit roughly along the same plane, but Pluto's path is much steeper, making it more erratic than the others. This peculiar orbital behavior adds another layer of complexity to the study of Pluto. One of the most captivating aspects of Pluto's orbit is its interaction with Neptune. For around 20 years during each orbit, Pluto actually comes closer to the Sun than Neptune, which defies what we might expect based on their positions in the solar system. This raises an important question: why hasn't Pluto collided with Neptune already? The answer lies in the gravitational influences of other celestial bodies, particularly other planets in the solar system. When Pluto was first discovered, astronomers were puzzled by its strange, erratic orbit. Unlike the other planets, whose orbits lie near the ecliptic plane, Pluto's orbit stood out due to its steep inclination and unusual shape. The mystery surrounding its orbit has since been explained through a concept in celestial mechanics known as the three-body problem. This concept seeks to understand the interactions between three objects, Pluto, Neptune, and the Sun, and how the gravitational forces influence each other. To predict their future positions, astronomers must consider how Pluto, Neptune, and the Sun interact with one another. This problem suggests that these three celestial bodies move in a delicate dance governed by mutual gravitational influences. Terms like asymptotic libration, scope libration, and VSK wobbling are used to describe this intricate motion. Astrophysicists believe that the reason Pluto and Neptune haven't collided is due to a phenomenon called libration. This refers to the way Pluto's orbit wobbles in such a way that when it crosses Neptune's path, their positions are separated by about 90 degrees. This separation helps prevent the two bodies from colliding. Libration also involves the vertical movement of a celestial body, which means that when Pluto comes close to Neptune or any other massive planet, it is often positioned far above or below the plane of their orbits, further reducing the risk of collision. An additional factor that keeps Pluto's orbit stable is the VSK wobbling. This term refers to the gravitational forces exerted by Pluto, Neptune, and the Sun on each other, causing each body to move in a specific way. The wobbling helps maintain Pluto's orbit despite its seemingly erratic nature. This delicate balance ensures that Pluto's path remains stable even when it ventures close to Neptune and the Sun. The stability of Pluto's orbit is remarkable considering its unconventional characteristics. The gravitational forces at play help keep everything in check, preventing potential collisions with Neptune or any other celestial body. The study of Pluto's orbit and the three-body problem is essential for understanding how celestial bodies interact in space. Mathematical simulations conducted in the late 1980s confirmed that Pluto's orbit, despite its unpredictability, remains stable over long periods. These simulations revealed that minor deviations in its initial conditions would only cause slight changes in its path. This stability has allowed astronomers to better understand Pluto's orbital behavior and refine their models over time. Computer models have also shed light on how other large planets, such as Neptune, Jupiter, and Saturn, influence Pluto's orbit. One of the most interesting aspects of Pluto's relationship with Neptune is the orbital resonance between the two. For every 2 orbits Pluto completes around the Sun, Neptune completes 3. This unique relationship helps stabilize Pluto's orbit and prevent a collision, even though their paths cross at certain points. Jupiter, the largest planet in the solar system, also plays a crucial role in maintaining Pluto's stable orbit. Its immense gravitational pull is strong enough to influence Pluto's path and keep it on a steady course. Some scientists speculate that Jupiter's gravity may have even prevented Pluto from being ejected from the solar system entirely. This interaction between Jupiter, Neptune, and Pluto creates a protective mechanism that helps maintain balance within the solar system. Saturn, another massive planet, also contributes to this gravitational dance. Its pull extends far across the outer reaches of the solar system, playing a key role in the stability of the system. The combined influence of Neptune, Jupiter, and Saturn helps keep Pluto on a safe and steady trajectory. Without these forces, the solar system would be much less stable, with the possibility of collisions or even the ejection of smaller bodies like Pluto. Understanding Pluto's orbit is crucial for predicting the future movements of celestial bodies. As scientists like Neil deGrasse Tyson continue to study the universe, they offer us a deeper understanding of the delicate balance that governs the solar system. The possibility of a Pluto-Neptune collision serves as a reminder of the complexity and unpredictability of space, urging us to continue exploring and studying the forces that shape the cosmos. The interaction between Pluto's orbit and Neptune's provides valuable insights into how planetary systems operate. Despite the erratic nature of Pluto's path, its relationship with Neptune illustrates how gravitational forces can maintain harmony in seemingly chaotic systems. The principle of orbital resonance between Pluto and Neptune is a crucial aspect of this balance, ensuring that even though their paths intersect, they never collide. This resonance, where Pluto's orbit is in a 2:3 ratio with Neptune's, is a key principle in celestial mechanics. For every 2 orbits Pluto completes, Neptune completes 3, and this gravitational synchronization ensures that the 2 bodies never collide. This delicate balance has kept Pluto's orbit stable for billions of years and highlights the self-regulating nature of orbital dynamics. In addition to Neptune's influence, other planets like Jupiter, Saturn, and even Uranus contribute to maintaining the stability of the solar system. Jupiter's immense gravitational force plays a protective role, influencing the orbits of smaller objects like Pluto and preventing them from being displaced. Some scientists believe that Jupiter's gravity may have even helped capture Pluto in its current orbit, preventing it from being sent into interstellar space. Jupiter's gravitational reach extends far beyond Pluto, affecting the orbits of asteroids, comets, and other small bodies in the outer solar system. This interaction between objects in the solar system highlights how gravitational forces work together to create order and balance. It is this balance that helps maintain stability and prevents chaos in space. The study of Pluto's orbit underscores the dynamic nature of space. While simulations and computer models provide valuable insights, they also reveal the uncertainties in predicting long-term orbital behavior. Subscribe to our channel,